when it comes to understanding real sequences or sequences of real numbers, it is important for us to visualize those sequences in order to understand them better. So let us do that using a few examples. For the first example, let us consider this sequence 2, 3, 3, 3, 3 and so on. Only the first element is 2, the rest of the elements are just 3's, right? Now there is a small notation here. We denote a sequence by this symbol xn and two brackets, right? So this symbol denotes this sequence. Now in order to visualize the sequence, we are going to use a coordinate axis, right? On the x-axis, we are going to denote the numbers of the set of all natural numbers, right? This is the natural number 1, natural number 2 and so on. And on the y-axis, we are going to denote the terms of this sequence, right? So here the first term is 2. Here f of 1 is equal to 2 in the sequence. So we plot 1 comma 2 here. We plot 1 comma 2. We plot 1 comma 2. And the second term in the sequence is 3. So we plot 2 comma 3. Third term is also 3. So we plot 3 comma 3. Fourth term is also 3. So we plot 4 comma 3 and so on. So this is the sequence that is formed. This is the kind of graph that is formed from this sequence, right? So it kind of goes like this. So that's what is written here. Now another notation. So we denote this sequence by this symbol, right? Xn with two parentheses on both of its sides, right? Now we denote the first term of this sequence using this symbol x1. 1 is the subscript, right? x1, the second term by the symbol x2, third term by the symbol x3 and so on. You can also have sequences like yn, an, bn and so on, right? For the second example, let us consider the constant sequence 3, right? The first digit is 3, first term is 3, second term is 3 and so on. Now if we plot this sequence, the first term is 3, so f of 1 is equal to 3, second term is 3, so f of 2 is equal to 3 and so on. So this constant sequence has this kind of behavior. Now this sequence, we consider 4, 3, 2, 1, 0, 0, 0, 0 and so on. So we plot 1 comma 4, 2 comma 3, 3 comma 2, 4 comma 1, 5 comma 0, 6 comma 0, 7 comma 0, 8 comma 0 and so on. So this these points denote the sequence. So these are the exact points: 1 comma 4, 2 comma 3, 3 comma 2, 4 comma 1, 5 and so on. So this sequence kind of follows this pattern, right? First it decreases and then it stays constant throughout. For the fourth sequence, we consider this 5, 4, 3, 4, 5, 4, 3, 4, 5, 4, 3, 4, 5 and so on. So if we plot this using a similar process, we get this zigzag kind of thing, right? So the terms of the sequence follow a zigzag pattern. For the fifth example, we have this sequence 1, 2, 3, 4, 5, 6, 7. The first term here is 1, second term here is 2, third term is 3, fourth term is 4 and so on. So we plot 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 and so on. So this sequence kind of follows this kind of behavior. Now since the first term is 1, second term is 2 and so on, we can say that the nth term is nothing but n, right? So that's what is written here. F of n is the nth term. Nth term is denoted by the symbol xn for simplicity, and it is nothing but n. So xn, the sequence xn, is defined by this rule that xn, the nth term, is equal to n. Next example, in this we have an alternating sequence the terms alternate, right? Minus 1, minus 1, 1, minus 1, 1, minus 1, and so on. So the first term, we plot 1 comma 1 to denote the first term, we plot 1 comma minus 1 to denote the second one, and so on. So these terms kind of also follow an alternating path or a zigzag path, whichever way we want to see. And also we have so many different ways to represent the rule here. So f of n, the nth term of this sequence, can be either represented as this minus 1 power n plus 1, right? If we substitute 1 here, we get the first term, which is nothing but 1. If we substitute 2 here, we get nothing but minus 1, the second term, and so on. Also, we can use this kind of representation, and also this, and it doesn't matter which one we follow, right? We can also represent this sequence in this way, right? 1 if odd, minus 1 if even. So if n is odd, the term xn is 1. If n is even, the term xn is minus 1. Now for the 7th example, let us consider this sequence. This sequence, I have not explicitly given this sequence. It is given by this rule xn is equal to 1 by n, right? So we substitute various values of n to find the various values of this sequence, right? So the first term is given by substituting 1 in the place of n, right? 1 by 1. The second term, third term, fourth term, and everything else is obtained by replacing n with the number, right? And 1 by 3 is approximately 1.33. 1 by 5 is 0.2. 1 by 6 is approximately 0.16. Now this is the sequence that is formed. So we plot 1 comma 1, right? Since the first term is 1, we plot 1 comma 1. So here we can see that I've used different scales. So the scale on the x-axis is kind of large, or rather I've squished the x-axis and I've expanded the y-axis, right? So that's why 1 is here, but 1 on the x-axis is here, very close to the origin, right? So the first term here is 1, so 1 comma 1 is plotted. Second term is 0.5, 1 by 2, right? So it is plotted. So this sequence kind of follows this diminishing behavior, right? We also have a similar sequence, right? 1 by 2 power n. It also can be enumerated as this 1 by 2, 1 by 4, 1 by 8, 1 by 16, and so on. And if we plot this sequence, we get a similar behavior, right? For the next example, we consider the first term of our sequence to be 1, the second term of our sequence to be 1, and the other terms to be the sum of the preceding two terms, right? We can recognize this as a Fibonacci sequence, right? So this sequence when plotted gives this kind of a behavior. The first term is 1, second term is also 1, third term is 2, fourth term is 3, and so on. Now for the last example, let us consider the sequence given by this rule xn is equal to 2n plus 1. So the first term is obtained by substituting 1 in the place of n. So 2 into 1 plus 1 is 3. 3 is the first term, 5 is the second term, 7 is the third term, and so on. And if we plot these points, we get a straight line kind of like this. Right.